Now usually as you move into real-world problems, it's not the solving part that's the most difficult. It's really this writing it part. Because you're not just told to solve a system of equations. Like that, for example, you actually have to come up with those equations on your own. Read through this by pausing the video and give yourself some time to process it, because I'll read it quickly and then jump in. The number of girls participating in high school soccer and track and field has steadily increased during the past few years. Use the information in the table to predict the year in which the number of girls participating in these two sports will be the same. So as we look at this, it seems like number of girls is going to be a variable. And it also seems like, since time's kind of going on, that another variable would be the number of years. So usually I like to be setting up my work and saying, well, X is going to be the number of years. And more specifically, from 2004 on, which means that if X was 1, that would represent a year after 2004. That would be 2005. And then Y is going to be the number of girls participating. So if we think about this very first row, and we deal just with soccer, then it seems to me like this is going to be a rate of change problem. We know that there's 309 as of now. That lends itself to being used as like a y-intercept. So here I am setting it up on the right. And then the number that matches up with that is that 8,000 more start playing every additional year. So I'm going to go with 8 times x, because 8 is going to be the rate of increase times the number of years, and then 309 being added onto that. For track and field, if that one feels comfortable, I think this is even more straightforward, because you'd be like, well, 3x, because it just goes up by 3,000 every years. And so like right now there's more playing track and field than there are playing soccer. But since track and field is getting more popular but not as quickly as the other sport, it can make sense that, eventually those will run into each other. And this problem doesn't lend itself as nicely to graphing as other problems will. And that's because we have these really large numbers. So as we go to the x's, maybe you're like, well, doing some trial and error to see what would happen. But let's graph all the way to 30. Here's 10 and 20. And then we can plug in some numbers too. Like you could use your calculator. 8 times 30 is 240. Plus this 300 would be roughly 540. So maybe it would be nice to go all the way up to 600 for this. So I'll use a bigger tick mark for 500 and then 1, 2, 3, 4. So each of these stops along the way is going to be 100. And if I were to graph this, starting with my first equation, here's 8x plus 309. So here's 309 being right around there. And then it goes up 8 every year. So we'll sketch the graph of that. And then here's 418 right there. And this rises more gradually. And the intersection of these two lines gives us where they would run into each other. So if this one is soccer, and this other line is track and field, then this is where they run into each other. And here's where like some significant guesswork needs to come into play. So like it looks like it's at 22. And if we plug in 22, to each value. We'll see what happens. So 8 times 22 plus 309 ends up giving us 485. Let's see what that means for the other graph. 3 times 22 plus 418 gives us 484. Now, you're not probably going to guess this as nicely as I did because I did some pre-planning. So when we have these graphing problems, and those end up being pretty darn close, we would say this is about 2,000. And then think about this, if this is 22 years later, we'd have to add 22 onto 2004, so this would be 2026. So about 2026 is the year that this would be crossing over with each other. But yeah, using graphing as a tool to solve things with very large numbers, you'd usually want to use softwares. So don't let that beat yourself up if you didn't get as close as I did. Now this will be challenging as well. A rectangular garden, so this is where you're thinking, okay, geometry, has a border around it consisting of 60 bricks. So before even reading the whole problem, I'm starting to picture a rectangle in my head. The width of the border has 2/3 the number of bricks as the length. How many bricks are along one length of the garden? So in dealing only with this value of 60, since this is the border, this would not be the area. This would be the perimeter. So we'll kind of tag out this and write P equals 60. Now the width of the border has 2/3 of this length. So that means that if this were x, then my width would be 2/3 of x. Now it's very possible that as you set these problems up, you'll make a mistake and put the 2/3 here. So let's talk about why this would be incorrect. This length would be 2/3 of the other side. But for this one, it wouldn't even really matter because you're only dealing with two values. But this side would be 2/3 of that, and not the other way around, the way I described it. But when you're talking about width and length, it's pretty arbitrary. All right. Now what this means is that we have an equation to set up. Now what this means is that as I would travel around my whole shape, I would get the value of x, not just once but twice. So I'm going to write 2x. And then as I'm dealing with 2/3 and 2/3, that's going to happen twice. So I'll write plus 2, and so that we can map our work out, not jump to saying 4/6. I'll instead write 2/3 x on the inside is going to be equal to 60. Simplifying, 2x plus 4/3 x gives me 60. And as we go to combine these fractions, 6/3 x plus 4/3 x equals 60, and I'm going to solve by multiplying over the reciprocal, which means that x is going to be 3 times 60 over 10, and 60 is 10 times 60 is 6 times bigger than 10, which gives us 18. Now really they're only asking for this measurement, but if we want to be nice, we can be like, well, that means that the dimensions are going to be 18 by, and then 2/3 of 18 would be 12. And then we'll put a little star by the 18 because we know that's what they really wanted. And let's see. I guess we'll add the word bricks. 18 bricks by 12 bricks. that's how you would do this one. Now, if you're wondering, well, why did we do it this way? Well, I think it's easier that way, but what you could have done to actually make this a equation, you'd be like, well, 2L plus 2W equals 60, because that would be the perimeter. And then you'd be like, well, the length has to be 2/3 of the width or the other way around. And then you could actually graph these and solve them. But in my opinion, this one lends itself more to a multi-step equation with only one equation, so I'll show it that way. Obviously, word problems are going to be a little challenging, so plan on seeking me for help on those and some coaching. And so this will finish up the notes for 5.1.